Everyone see the screen? Okay, I
I
see
can see
heads
the screen.
nodding. Cool. So, welcome to Network Service Mesh. And so, um, I'm Frederick Kautz, Head of Edge Infrastructure at Doc AI, and we have Bobby.
Hey everyone, thanks for joining.
So, Bobby is Staff VP of AI Engineering at Anthem.
So let me kick us off because when we talk about different technology and we talk about what is useful, what I want to do is I want to set the business context on the why. Why is Anthem doing this? Why are we spending time working in this space? So back in 2015, we had a large cyber breach or data breach. And those of us that were at Anthem, we know exactly where we were at the time it was announced. We knew when the pains that we went through. And as a result, we have beefed up our perimeter security, and we have a very talented network security and InfoSec team that works to protect our perimeter security as well as internal applications. And that comes with a cost, especially as we build scalable next-gen applications that reach out and touch different members and protect a growing amount of healthcare data. And then we've got as everyone may be aware, at least in the US market, there is just a continuous rising cost of healthcare. And that has driven the need for innovation. It's driven the need for, we've heard it many times in different ways, but faster, better, cheaper, right? Ways of deploying applications that are secure, that are scalable, and that are, available at a moment's notice. So as a result, we've been adopting zero trust network architecture and security model to drive cloud native app development. So groups that are participating, the open source projects are participating, and this is just a few of them, but the NSM, the OPA or the Open Policy Agent, Spiffy Spire are all helping us work together. And there are different tool sets that come together to help us build this foundation. Next slide, please, Frederick. So as a result of that, there's a particular application that I'll talk about, or application set that we'll talk about, and it's called HealthOS, at least within Anthem. And the idea of that is we're putting together an AI and security first set of applications that will come through multiple front end platforms. And what's powering this is our secure data set. There's a large amount of data we have within Anthem that we do the course of doing our business that we have available, and we use that to power these applications that are being built. We have a few in progress right now. Once we validate that, we will take HealthOS and we'll make it available to the third-party development groups. So privileged groups that can come within our four walls and start to work with these data sets and unlock this supply and demand in the marketplace. We believe there's a ton of opportunity, a great deal of opportunity across the healthcare ecosystem. Next slide, please. So just to give you a quick idea of what this stack looks like, I'm going to start at the bottom and work our way up through this stack here very quickly. But we've got a large amount of data from different various data sources. Think of these as core operational transactional system data sources that are used to process everything from claims to lab values, et cetera, as well as all of our operations type data or admin type data. We've got third-party data that's being piped in that we're using as a core to our business, as well as other solutions and services that we've been building, whether it's call center applications or various channels like that. And on top of that, we've put together a data ontology, if you will, and there's access APIs as well as MDM that we're following for master data management to make that available and to abstract everyone from the that data layer that's down below what we live in. On top of that sit various channels or apps that get built and that are actually all in use today. So everything from a lifetime patient record or a longitudinal view of a patient record to AI-driven insights and population health or care gap awareness tools. And so we sit from there. From that point on, our SDK sits on top of that. And in that SDK, we've been developing apps that that are various types of products that start to deploy useful bits of functionality out to the world. Everything from chatbots to other types of channels that we can deliver, and those all sit on this HealthOS stack and platform. So they are security first application. So it's not, security is not something we think of after the fact. It's core to what we do using SPIFFE, Spire, OPA, and NSM. We put those together. The code stack sits there, as well as a design system that we've put in place that help with the look and feel and the performance of all these different apps. So that's where we're starting. This is where we've begun, and NSM is core to our journey as we begin to look at this. And zero trust is, we're a big believer in zero trust being one of the big answers to how we can scale next generation applications within the HealthOS system. All right, next slide.
So let's start a little bit about how NSM fits into this picture. And so I'm one of the people who helped architect HealthOS, just for some context. And what we're looking at is multiple systems communicating with each other. Many of them may not be in the same organization. And so there's a lot of complexity there. And what we're trying to do is we're trying to establish the system in such a way that we have three basic patterns. From the pattern of the application developer, which we're calling the user in this scenario, they have a workload, typically a pod in Kubernetes. They want to connect to something that is outside of their system. Could be something in a secure environment. Then they just want to be able to ask for a network service, and they receive it. From the operator's perspective, the operator wants to say, well, what does that really mean? I want it to go by policy through a firewall, intrusion detection, through VPN, and they can declaratively state the type of things that they want, and it gets composed into the system. From the vendor of the network service, what they want is, they don't care about what comes before them or after them. They want to say, I'm a network service. I can speak in this specific way. I provide this type of a service with a certain payload, such as IP. And I don't care what comes before or after. I just want to handle what I need to do based upon my configuration. So NSM, based upon where you're coming from, appears to have this type of property to you. And it abstracts in a way that you don't have to worry too much about what is the user doing, what is the operator doing, or vendor, depending on who you are. So one of the things that we're pushing towards is a zero trust environment. And when we say zero trust, typically you have to look at the past. What does this mean? So historically, most systems, you have a trusted network, and there'll be workloads on that trusted network. And suppose you want to connect to a workload that's outside of your trusted network, inside of another one. Then what you typically have to do is you have to join up these networks. You have to do things like subnet deconflicting and so on, and try to work out or perform network address translation and try to cook these things together. And your root of trust is primarily at the network level, and you put your access control list with your firewalls to determine who can talk to who. And your workloads may have some additional features, but it's not core to your infrastructure. It's something add-on that the applications do. When we say zero trust, what we specifically mean is that this is now this trust from workload to workload is now part of your infrastructure, and it gets attested and validated. And we still have networks. You could still have a perimeter that is your network, but it's no longer your central root of trust. Your central root of trust is the actual workload itself. It receives a cryptographic identity that says, I am who I am, and it's capable to use that identity to connect and make use of services. And if you notice, the tunnel is now connected from trusted workload to trusted workload. So we also have on the horizon 5G, and this is a little bit forward-looking in terms of where the industry is going as a person who's working on network service mesh. And so many companies are starting to look at, well, how do we gain access into such a system? And so a couple facts: 5G radios are being deployed rapidly. The current backend infrastructure for those radios is currently 4G, but the next generation telecom infrastructure is being designed today, which is going to be horizontally scalable. The reason it's going to be horizontally scalable is when you start to look at the density. And so people, they look at it and say, oh, I get all this fast bandwidth. Actually, the real exciting part about this stuff is around how many devices you can put in a given area. And so this is going to enable machine to machine work. This is one of the key things that is necessary to actually realize the vision of IoT. And what will happen is that there are edge data centers that are being designed, and there's some in early deployment where an edge data center you can think of as a data center that's very close to you. It may be within a mile or two from where you're at, that your devices are able to connect to. And so when we start to look at this in an environment where, like, what does this mean to organizations, and not just healthcare, but just across the system. So I came up with this particular example to show what a system may look like, and you can replace hospital with your corporate network or corporate environment. So what ends up happening is you may have a device that, instead of using Wi-Fi, uses 5G to connect to your local network and may connect to your local data center. That system may then connect through an edge data center to a cloud computing platform. And instead of hosting the firewall and intrusion detections directly themselves, they may end up tying directly into an edge data center that provides these type of things as a service. So you may have firewall as a service, intrusion detection as a service, all the way up leading into your cloud platform. So each of these particular things may be owned by a different entity. You may have the devices owned by a different entity. You have, in this scenario, the hospital network. The edge data center is another identity. Firewall and intrusion detection as a service are different identities, and of course the cloud computing platform itself. And don't forget, the connections between them are also managed by service providers, who will have their own set of things that they want to interweave in. So identity becomes very important in this scenario, and the way that we avoid operational complexity in a scenario is we want to avoid having to deconflict subnets, avoid having to manage IPAM at a global level. You still need IPAM, but we don't want to say, okay, let's go deconflict everything. Let's go try to reduce this scope of what you're trying to reason about. Reduce the workload privileges and negotiate the tunnel parameters. And NSM is able to play a key role in this particular space with that identity at the root. So if you're looking to help us on our journey, please join us in the NSM community. There's GitHub, Slack, there's weekly meetings. And if you're looking to help join us with implementing some of the things that you have seen on here, please contact either Bobby or myself, and we'll get you started. Thank you very much.
Excellent, thank you.